All right, so in this video, we're going to talk about graphing exponential functions. So just to give us an example of what an exponential function might look like, this is what we consider an exponential function. It's an exponent because our variable or our x is in the exponent of the function. So that's how we know it's an exponential. There are more complicated ones than this as well. Graphing this, first thing we might want to do is create an XY table, see what's going on, and that will be very useful to do in our calculator. You can go in here, edit the function, and do something like 2 to the x. Let's start our table at 0, and let's calculate it. So we can see here, we have one side of our values, 0, 1, 2, 3, we've got 1, 2, 4, 8, 16. And as we talked about the other day in class, the pattern here is that we're always multiplying by 2. And this totally makes sense with what we have as our equation, because how do you represent 2 times 2? You use exponents, right? So however many times we need to multiply by 2, that's what that x represents. So here we multiply by 2 once, by 2 twice, by 2 3 times, and that's exactly what we're getting. So let's just start with that half of the graph. So in this half of the graph, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. On that side of the graph, we see what we call exponential growth. So at 0, we're at 1, 1, we're at 2, 2, we're at 4, 3, we're at 8. Let's just assume this is right. I'm too lazy to count it off. And 4, we're at 16. So this is what one half of our graph looks like. Shooting off very quickly towards very large numbers, right? If we keep doubling something, you can see as we move down our list, we're very quickly going to shoot into millions of things, right? It only takes us up until the 20th point before we're at a million. So we could have made our y even crazier. Now we need to think about the other side of the graph, the negative numbers. So for the negative numbers, you can see -1, go ahead and add some more tick marks on this side. -1 is at 1/2. -2 is at 1/4. -3 is at 1/8. We're just dividing by 2 each time as we go, or multiplying that denominator by 2. 1/16, 1/32, 1/64. We're getting to these smaller and smaller numbers, and if we wanted to, remember, Carlos pointed this out in class, I can make sure that the number I want to look at is highlighted, and then I can press the little squiggle button, and it tells me what this is. It is decimal. So already 9 steps over to the left, we're at 0.002. So very, very small. Now we talked about this in class. It is never possible. We cannot ever take 2 to the x and get out 0. That doesn't work because there's always going to be a little bit left over. If we keep cutting this in half, there's always going to be just something to cut in half. It's going to get smaller and smaller, but it never stops. And that means that we're reaching what we call an asymptote. We talked about this in class. So this here is what we would call a horizontal asymptote. And our horizontal asymptote happens at this line, which happens to be the line y is equal to 0, because we can never get out y is equal to 0. We also talked about in class all of the other things that we usually ask for with graphs, right? We've done this with the parabola section we just finished. We may ask, what's the x-intercept? In this case, usually that's when we set this thing equal to 0, and we just said it can never equal 0. So this does not have an x-intercept. Well, what about a y-intercept? Well, for a y-intercept, we can see exactly that on either our graph or on our table, or we could do this algebraically by setting x equal to 0. So this would be 2 to the 0 or 1. And we should give that out as a point, so this is 0, 1. We could also be asked about our domain. What values are we allowed to plug in here? And we can either do our scan of our graph left to right, and if we do a scan, we can see left side we see an arrow, and then the right side we also have an arrow over here. So this is going to go from -infinity to infinity. You could also just think about like what am I allowed to plug in? Well, negatives worked in my little calculator. Nothing is giving me out error, so there doesn't seem to be any problems with things I'm plugging into this equation. And then lastly, we'd want to talk about our range. So what does our range look like? Now the range does have some problems. We'd like to do our scan from bottom to top. And if we look here, we know we can't get out y is equal to 0, right? We've been talking about that again and again and again. And in fact, we can't get out any negatives either. It's not possible to take 2 and multiply it by itself and get out a negative number. So our range starts at 0. Obviously, we can get all these giant numbers, so it goes up to infinity. We can never reach 0, so we'll use a parenthesis. And we can never reach infinity, so that gets a parenthesis as well. So that's our range. It's always going to match up with our asymptote. These two things will always align with each other. So I want to do a couple more of these. I'll give you the opportunity to try graphing them and finding all those pieces in separate videos. But ideally, I'll give you a chance to pause in those and try something on your own.